Welcome all. Let's know about atoms and molecules. What are atoms and how molecules are obtained from the atoms? Here you can see the structure of an atom. In the center of an atom, nucleus is there which comprises of protons and neutrons, and electrons are revolving around the nucleus of an atom. Now, how the nucleus is formed and how electrons will be revolving around it, let's discover. The invisible and unknown form of matter. The idea of divisibility by Indian philosophers, that is Maharishi Kannan, has postulated that if we keep on dividing the matter, which is called Padarth, at that time, we will get smaller and smaller particles. And soon we will achieve the smallest of particle called Parmanu, which may not divide further. Next, Pakuda Katayama, he postulated that there are various forms of matter because the particles of matter exist together in combinations. The idea of divisibility by Greek philosophers, Democritus and Leucippus, suggested that when we keep on dividing the matter, there comes a time when no more division of particles can take place. Such particles are called atoms, which means being indivisible. But all these ideas were not backed up by many experimental pieces of evidence until Anton L. Lavoisier provided two laws of chemical combination. Next, law of chemical combinations, that is law of conservation of mass and law of constant proportion, which is also known as law of definite proportion. Law of conservation of mass says that in the sum of the mass of reacting mixture and the product formed remains constant. Antoine L. Lavoisier gave this law in the year 1789 based on the data he obtained after carefully studying numerous combustion reactions. He says that as mass can neither be created nor be destroyed. For example, combustion process, burning of wood is a conservation of mass as the burning of wood involves oxygen, carbon dioxide, water vapor and ashes. Chemical reactions to get one molecule of water with the molecular weight of 10 hydrogen with molecular weight 2 is added with oxygen whose molecular weight is 8, thereby conserving the mass. Ten grams of calcium carbonate produces 3.8 grams of carbon dioxide and 6.2 grams of calcium oxide. Represent this reaction in terms of law of conservation of mass. According to law of conservation of mass of reactant is equals to mass of product. Therefore, 10 grams of calcium carbonate is equals to 3.8 grams of carbon dioxide gas plus 6.2 grams of calcium oxide. Therefore, 10 grams of reactant will be equal to 10 grams of products. Hence, it is proved that law of conservation of mass is followed by the above reaction. To verify law of conservation of mass by an experiment. According to the law of conservation of mass, during any physical or chemical change, the matter is neither created nor destroyed. However, it may change from one form to another. Below, we have listed an experiment that will help you to verify the law of conservation of mass. What are the requirements? H-shaped tube, which is also known as Landon's tube, sodium chloride solution, and silver nitrate solution. Sodium chloride solution is taken in one limb of the H tube and silver nitrate solution in the other. Both the limbs are now sealed and weighed. Now the test tubes are awaited so that the solutions can mix up together and react chemically. The reaction takes place and a white precipitate of silver chloride is obtained. The tube is weighed after the reaction has taken place. The mass of the tube is found to be exactly the same as the mass obtained before inverting the tube. This experiment clearly verifies the law of conservation of mass. Next comes law of definite proportion, given by Joseph Proust, a French chemist, stated that the proportion of elements by weight in a given compound will always remain exactly the same. In simple terms, we can say that irrespective of its source, origin, or its quantity, the percent composition of elements by weight in a given compound will always remain the same. For example, if you take a sample of water, no matter from wherever you have taken, either from sea water, river water, pond water, well water, RO water, or any kind of filter water or normal tap water, the composition remains the same. The atomic theory was first given by John Dalton, which acted as an explanation of the two laws, that is, the law of conservation of mass and the definite proportion. As per theory, all matter, whether it is an element, a compound, or a mixture, consists of tiny invisible particles called the atoms. The postulates of the atomic theory by John Dalton first is the matter is made up of tiny particles called atoms which cannot be divided. Second, atoms are never formed or destroyed during a chemical reaction. Atoms of an element exhibit same nature. They have the same size, mass, and character. Atoms of different element exhibit variant nature. They do not have same characteristics. Atoms forms compounds by combining in a ratio of whole numbers. A compound contains a constant number and kinds of atoms. So what actually an atom is? We can call atom as the building blocks of matter. Just like bricks are the building blocks of a building. So, what is the size of an atom? Atoms are extremely small. Their size is measured in nanometers, where 1 nanometer is equals to 10 raised to minus 9 meter. Symbols for atoms. The symbols for representing an atom are generated from the first two letters of the element's name. The first letter is always in uppercase, that is capital letter, while the second letter is written in lowercase, that is the small letters. So here comes the examples, the first 20 examples of the elements with their atomic number and their name and the symbol. So these 20 elements you need to remember. On your right hand side you can see the symbol proposed by the Dalton. The atomic mass is again defined by the Dalton's atomic theory. He suggested that each element has a distinguishing atomic mass. With this theory, the law of constant proportion could be explained easily. But it is indeed difficult to evaluate the mass of an atom, since the size of an atom is relatively small. Therefore, scientists started evaluating the mass of an atom by comparing it with the mass of a standard atom. Earlier, 1/16th of the mass of an oxygen atom was used as a standard for calculating the mass of other elements. Now, carbon-12 is considered a standard atom for calculating the mass. Its atomic mass is 12 unit. Thus, we can say that one atomic mass unit is the mass of 1/12 the mass of a carbon-12 atom. Here is the list of atomic masses of few elements. Hydrogen 1 unit, carbon 12, nitrogen 14. More or less, if you double the number of protons, you will be getting the number of atomic mass. Or we can say if you double the atomic number, you will get the atomic mass. But somewhere again it is different. For example, sodium. 11 is the atomic number of sodium, but 23 is the atomic mass. But in case of magnesium, sulfur, calcium, it is exactly double the atomic number. Whereas chlorine atomic mass, we have taken the average atomic mass of its isotope. Can atom exist independently? As we say, atoms are very small. So can atom exist independently? Atoms cannot survive independently. So atoms join together and form molecules or ions. Now why atoms cannot survive independently? Because of their instability. So what is molecule? A molecule is a collection of various atoms that combine chemically with each other. I repeat, a molecule is a collection of various atoms that combine chemically with each other. These atoms are bound together by certain forces of attraction. Atoms of the same element or different elements can bind together to form molecules. For example, water molecule, H2O, hydrogen gas, H2, oxygen gas, O2, right, where we combine similar, and water, it's of different elements. Hydrogen chloride, again different element. Therefore, a molecule is the smallest particle of a substance that can exist independently and shows all the properties of that substance. Molecule of an element is equals to combination of similar types of element. Hence, the molecules we have different types, right? Number of atoms in a molecule of an element gives you the atomicity. I repeat, number of atoms in a molecule of an element gives us the atomicity. And based on the number of atoms, the molecules are classified in several types. Say monoatomic, diatomic, triatomic, tetraatomic and polyatomic. Monoatomic are all the metals which exist in monoatomic form, whereas all the gases exist in diatomic form. For example, hydrogen gas, oxygen gas, nitrogen gas, chlorine gas, bromine gas, iodine gas, and so on. Whereas triatomic, you can say the few exceptional cases are there, like ozone, it's a triatomic molecule, but of the similar atoms. Then tetraatomic is E4 and octaatomic or polyatomic it is S8, means sulfur. Now what are ions? You can see that two atoms talking together. One atom says, I am about to lose an electron. The other is asking for the confirmation. Are you sure? The atom that wants to lose an electron says, yeah, I am positive. The other atom, one which is accepting the electron, becomes negative. Hence, when an atom lose or gain electrons. It acquires charges. The one which lose electron, the one which lose an electron acquires positive charge, whereas the other which gains electron acquires a negative charge. Can anybody tell me why the one which lose an electron becomes positive in nature? Yes, we know atom is electrically neutral. Now, meaning me atom electrically neutral means an atom consists of same number of protons which are positively charged and same number of electrons which are negatively charged. So when an atom loses an electron, it means the number of electron is reduced by 1 than the number of protons. Therefore, that atom acquires positive charge because we know protons are positively charged whereas electrons are negatively charged. In the same manner, the other atom gains an electron. That means it gains one negative charge. Therefore, it acquires negative charge. Let's see an example over here. Sodium atom is saying, just take away my electron. Whereas chlorine is accepting it happily. Don't mind if I do it. In this way, the ions are formed. We have few examples of molecules of compounds, how a compound is formed by combining element and how compounds differ from element that we have already studied in chapter number 1 and 2. Hence, if water is a compound, then which are the elements? That is hydrogen and oxygen. How many hydrogen? 2 hydrogen atom and 1 oxygen atom. Therefore, the atomicity of water molecule. Any guesses? Yes, it is 2 plus 1, 3. The atomicity of water molecule is equals to 3. In the same manner, the atomicity of ammonia will be 4. Carbon dioxide will be again 3. Hydrochloric acid 2. Nitric acid, it is 5. 3 plus 1 plus 1, 5. Sulfuric acid, it is 2 plus 1 plus 4. It is 7. And you need to remember the formula of the given compound. Common ions and their symbols. Aluminium. Why it is aluminium 3 plus? Because aluminium have 13 atomic number which says it has 13 electrons and 13 protons. Now as per Bohr's atomic theory, it says that atom will be stable only if it is having 8 electrons in its outermost shell. Hence, aluminium loses 3 electrons and that is the reason why it acquires 3 positive charge. Similarly, all the atoms, those who are positively charged, they loses that many electrons and acquires those positive charge to attain the stable configuration. The atoms with the positive charge, they are termed as cations, and the atoms after gaining electrons, they are termed as anions, having the negative charge. Now this anions name is derived from the electrode name anode, A-N-O-D-E, whereas cations is derived from the electrode names cathode, C-A-T-H-O-D-E. So these are the ions that you need to remember with the charges. Let's proceed further and learn how to obtain a chemical formula and why it is necessary to learn. We use a chemical formula to represent the composition of a compound in the form of symbols. To write a chemical formula, you must know two basic things. First, symbol of elements. Second, valency. What are valencies? The charges that it has. Right, valency is derived from the word valence electron. Valence electron means the electron present in the valence shell, that is outermost shell. So valency is the combining capacity of an atom or an element. Let's see. Valency, it is also known as the combining capacity of an element. It also explains how atoms of one element will mix with the atoms of another element. Hydrogen H symbol, valency is 1. Helium, valency is 0 because it is already coming under the stable electronic configuration, that is the noble gases. Lithium, it loses 1 electron, so positive 1. Beryllium, it will lose 2 electrons because beryllium atomic number is 4, hence it is 2 electron in its valence shell. So you can see here how the valency is being acquired by a particular element. Now basic rules that you need to follow while writing a chemical formula. First of all, valencies of all the ions must be balanced. In a case where both metal and non-metal substances are present in a compound, the name of the metal is always written first in the chemical formula. For example, sodium chloride, that is NaCl. Sodium is a metal, chlorine is a non-metal, but when it forms a compound, that means when it forms an ion, it changes into chloride. So the name of the chemical compound becomes sodium chloride. In case of polyatomic ions, the ions is written in the bracket form before writing the number of ions associated with it. In case of a single ion, there is no need to mention the ion in the brackets. Let's see an example to understand clearly. Binary compounds means compound that consists of two different elements. How to write the formula of a compound? So write the symbols of the corresponding elements of the compound as explained above. Then write the valencies of the elements of the compound and cross over the valency of the elements like this. Right, first of all, sodium oxide. Sodium means sodium metal. Oxide means oxygen. The valency of sodium is +1, whereas the valency of oxygen is -2. Now, by the crisscross method, this +1 will go to oxygen and -2 will go to sodium. Therefore, we write Na2O. Similarly, for sodium sulfide, red sulfur, that is sulfide. So, sulfide is -2, hence the formula will be sodium sulfide. Whereas for aluminium chloride, it will be AlCl3, and magnesium hydroxide, it is MgOH twice. Now here you see that is the polyatomic ion. Hydroxide, it is the polyatomic ion. Hence we keep it in the bracket form, the whole in the bracket form. Now the important topic, that is mole concept and molar mass. What is molecular mass? It is the summation of all the atomic masses in a molecule. Molecular mass is expressed in atomic mass unit. For example, the molecular mass of nitric acid can be calculated as sum of atomic mass of hydrogen plus sum of the atomic mass of nitrogen and 3 into atomic mass of oxygen because 3 oxygen atoms are present. Hence, by substituting the values of atomic mass of different elements, we get the total molecular mass as 63 unit. Next, formula unit mass. How to calculate the formula unit mass. That is similar way as we have done for the molecular mass. The only difference is the formula unit mass is used in case of substances that constitute ions. For example, sodium chloride, they are the ionic compounds. Sodium atomic mass is 23, chlorine atomic mass is 35.5 and 1 into 23 because it contains only one sodium element, whereas 1 into 35.5 because it contains only one chlorine atom in sodium chloride. Hence, the resultant mass is equals to 58.5. Therefore, we can say the formula unit mass is equals to the molecular mass. Here comes few more example. Here you can see it is same as we have calculated for molecular mass. Now to calculate the formula unit mass or molecular mass, only thing that you need to know the atomic mass of that particular element. So molar mass means mass in grams of 1 mole of a substance. Molar mass means mass in grams of 1 mole of a substance. Mole gives us the amount of substance containing the same number of atoms, molecules, ions or other entities as the number of atoms is exactly 12 grams of carbon 12. 1 mole is equals to 6.022 into 10 to the power 23 atoms. This value is given by the scientist Avogadro. Let's do an example. How many moles of sugar molecules are there in 1000 grams of sugar? What is the formula to calculate the moles? Moles is equals to mass upon molar mass. I repeat, moles is equals to mass upon molar mass. So if moles is equals to 1000 grams, that is mass given in the question is 1000 gram of sugar, and the molecular mass, that is molar mass of sugar, is 342.26. How did we calculate? The chemical formula of sugar is C12H22O11. I repeat, it is C12H22O11. By calculating the molar mass with respect to atomic masses, we get the molar mass is equals to 342.26. Therefore, by substituting the values in the given formula, we obtain moles is equals to 2.92, approximately 3 moles of sugar. IUPAC have defined atomic mass unit. What is IUPAC? It is International Union of Pure and Applied Chemistry. I repeat, it is International Union of Pure and Applied Chemistry. Defines one atomic mass unit as 1/12 the mass of carbon 12, as carbon 12 has a mass of 12. Now moles, atoms or molecules and grams, these are interconvertible. So if atoms or moles are given, we can calculate the grams. If grams and moles, these are the 3 quantities. Out of these 3 quantities, if any 2 is given, we can find out the third one. by using this relationship. One more relationship. So mole concept we can interpret over here. We can say that two molecules of carbon combine with one molecule of oxygen to form two molecules of carbon dioxide. We can also say this, that 24 unit of carbon molecules. How 24? Single carbon atom having 12 units. So 2 carbon atom it is 24 units. Similarly, 1 oxygen having 16 units, 2 oxygen having 32 units. Combines to form 44, 2 molecules of carbon dioxide gas. That is 32 plus 12. It gives 44. So here will give 44 into 2, that is 88 unit of carbon dioxide molecules. I repeat, 88 units of carbon dioxide molecules. So 88 units of carbon dioxide molecules is obtained. Therefore, we can characterize the quantity of a substance by its mass or by its number of molecules. A chemical equation directly indicates the number of molecules participating in the reaction. Thus, it is convenient for us to refer to the number of substance in a chemical reaction as number of molecules or atoms. Mole is a numerical quantity that has a mass equal to the atomic or molecular mass of species, atoms, molecules, ions or particles. That is, mole is equal to given mass upon molar mass. Hence, 1 mole of any substance is equal to 6.022 into 10 raised to 23 number of particles. That means it can be atoms, ions or molecules. This value we got it from the Avogadro's constant. So this is also called the Avogadro number or Avogadro constant, which is represented as N, O, or many times you will be able to find by N, capital A. Both are correct. The mass of 1 mole of a substance is the same as that its atomic mass or molecular mass expressed in grams. What is gram atomic mass of a substance then? The atomic mass of a substance when expressed in gram is known as its gram atomic mass. Similar manner, gram molecular mass of a substance means the molecular mass of a substance when expressed in grams is known as its gram molecular mass. For example, the atomic mass of sulfur is 32 units. Therefore, the gram atomic mass of sulfur is 32 grams. Also, 32 unit of sulfur has 1 atom of sulfur. Therefore, we can also say 32 grams of sulfur has 1 mole atoms. That is equal to 6.022 into 10 raised to 23 atoms of sulfur. Similarly, we can say that the gram molecular mass of carbon dioxide is 44 grams. But we know that in the case of chemical equation, mole is the measuring unit. Therefore, 1 mole is equal to 6.022 into 10 raised to 23, which is equals to relative mass in grams. Wilhelm Oswald introduced the word mole, which actually means a heap or a pile. Therefore, we consider a substance as a heap of atoms or molecules. Thank you. Have a nice day.